So in this video, we're going to talk about the next phase of calculations for the hole-in path using trigonometry now. We're going to use trigonometry to find these angles more accurately than a protractor can. The protractor has these dash marks at every whole degree angle, but we're going to try and actually calculate it more to the tenths or hundredths place. So we're going to call this angle, call it theta 1. All right. So theta 1 we're going to find using trig, and in this case we're going to mark this one opposite, the cross from theta. 4.5 is going to be your adjacent side length, and this is going to be your hypotenuse. Okay, you're free to use whatever trig function you want, sine, cosine, or tangent, since we have all three of these. I'm going to use tangent, the opposite adjacent side length, so it's going to be tangent of theta 1 equals 3.85 over 4.5. Just some housekeeping things to keep track of. When you actually turn in your project, you'll be showing your work, much like what I have written down here. And if you're used to showing a bunch of scratch work and kind of making up your own math language, it's going to be difficult for us to follow it. So you can have your own version of your scratch work initially, but when you turn in your final copy of everything, redo your work so it looks as the way we taught it, nice and neat, precise, laid out correctly. In order to solve for the theta, we're going to take the inverse tangent on both sides in order to undo what tangent does. So that's what it looks like. So if I take a theta angle, whatever the angle is, do the tangent of it, do the inverse tangent of it, you're left with just the angle. So essentially you're solving for that angle, and we've now gotten rid of the tangent by doing the inverse tangent on both sides. Now on the right side, the inverse tangent of 3.85 over 4.5 is something you're going to type in your calculator. So we're going to inverse tangent 3.85 divided by 4.5. So it should look like that. Close your parenthesis. 40.54 or 40.55 degrees is your theta. So 40.55 degrees. Double check to make sure that your calculator is in degree mode before you type that in. So I know that angle is 40.55 degrees. So somewhere on here, if you could find a spot for it, 40.55 degrees. You're going to repeat the same process over here as well. In this case, we're going to have this angle right here. And since we have this angle, we'll call theta 2. And I guess you can use Roman numerals or numerical, it does not matter. That's going to be theta 2, and you repeat the exact same process. We'll call this opposite. We'll call this adjacent relative to this triangle, and then we'll call this the hypotenuse. And again, you have choice. You have the choice for whatever trig function you want to use: sine, cosine, or tangent. It should not matter which one you use. The only difference here between the three sides, these two I measured with some human error, and this is accurate based on how accurate your measurements are. So if you're not doing a good job of measuring this, your hypotenuse is going to be off. So if you use this along with these two, you should be in the same relative window of error, because you're using the calculations in order to find this hypotenuse. So you can use tangent only, or you can use sine only, you can use cosine only, it does not matter. But the important thing here is to measure correctly. Take your time with measuring, take your time with calculating, make sure your calculator is in degree mode, and then find your missing angles throughout the entire path. So this angle here, this angle here, 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 and keep going until you get to the very end. So a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 angles. You're doing 11 trig calculations like this. Keep things labeled correctly. name the number of thetas. Start with theta 1 and then keep going to theta. In this case, theta 11 will be the last one. And keep your work neat so you can go reference it back when you need to make changes or adjustments. All right, and that's it.